All right, number 6 says the Zonda Information and Telephone Company calculates a customer's total monthly cell phone charge using the formula. And there it is. Where C is the total cell phone charge, B is the basic monthly fee, R is the rate per minute, M is the number of minutes used that month, and T is the tax rate. Solve for M, the number of minutes the customer used that month. Okay, a couple of different ways you can do this, but probably the one that's going to make the most sense to you is for us to do the full method. Since we have two binomials here, we're going to do the first, outer, inner, last. The first, what's B times 1? So C is equal to B. The outer, what's B times T? BT. The inner, RM times 1 would be plus RM. And then the outer would be plus RMT. Now, whenever you have those written together like that, that means B times T, or R times M, or R times M times T, right? Right. But now we got to try and solve for M, which means we want to, let's subtract by B and BT from both sides. So that cancels them over here, and let's rewrite it over here as C minus B minus BT is equal to RM plus RMT. Now, we're going to factor something out. And normally when you're factoring out, you want to factor out as much as you can. And since R and M are both in this right side of the equation, we can factor out RM, but that doesn't help us. What are we trying to solve for? M. So we want to factor out the M on all of this. So to factor out an M, we would say M times what gives us RM? R. M times what gives us RMT? Well, that's just RT. So let's rewrite it. Now we wanted to solve for M. How do we solve for M? Well, that's M times what's in parentheses there. So we're just going to divide by what's in parentheses. And that is your answer. C minus B minus BT over R plus RT equals M. Which means the total charge of the cell phone minus the monthly fee, minus the monthly fee times the tax, divided by the rate per minute plus the rate per minute times the tax. But we don't care about that. We just want to find out what M is. And there it is. All right, page 6. Students and adults purchased tickets for a recent basketball playoff game. All tickets were sold at the ticket booth. Season passes, discounts, and etc. were not allowed. So any other tickets were not allowed. You basically just had to buy the adult and the student tickets. Okay, that's all that is available at this particular time. Now, student tickets cost $5 each. Adult tickets cost $10 each. A total of $4,500 was collected, and 700 tickets were sold. So we're going to find a system of equation here. Basically, essentially, that's what we're going to do. Now, we know that the student tickets were $5 each. So let's say 5 times S plus the adult tickets were $10 each, right? 10 times A. And now how much was sold altogether? 4,500. Right? That's the dollar amounts. Now we've got to talk about how much of each is sold. Do you know how many student tickets were sold? No. Do you know how many adult tickets were sold? No. Do you know how many were sold altogether? 700 were sold. So there is the A. That is the system of equations that you would write. There's your two equations that you're going to solve. Now, assuming that the number of students and adults attending would not change, how much more money could have been collected at the playoff game if the ticket booth charged students and adults the same price? Okay, so if all of them were $700, well, how much was sold? $4,500 worth, right? But if they had sold every ticket for $10, how much would they have made? 700 times not 100, times 10 is equal to 7,000. So we would say 7,000 minus 4,500 would be $2,500. So instead of giving the student discount, if they would have just sold everything for $10, they would have made an extra $2,500. T says, assuming the number of students and the adults attending would not change, how much more money could have been collected at the playoff game if the students' price was kept at $5 per ticket and the adults were charged $15 per ticket instead of $10 per ticket? Well, here we're going to have to now do our, we're basically going to have to solve for our A and our S. Right? We got to solve for our adult tickets and solve for our student tickets. Now, the way I would do this is probably what I would do is set this up here. Let's move up here for T and solve. So I could set S to equal 700 minus A, right? If I subtracted A from both sides, now I have 700 minus A is equal to S. Everybody see that? Now, if I plug in for S, 5 times 700 minus A plus 10A, that is equal to 4,500. Oh, stop. 100. Now, if I said 5 times 700, that is 3,500, minus 5A plus 10A is equal to 4,500. Well, let's subtract 3,500 and subtract 3,500. That is 1,000 is equal to, what's negative 5A plus 10A? 5A. Divide by 5, divide by 5. 1,000 divided by 5, A is 200. So if A is 200, what does 5 got to be? What does S got to be? 500. Okay. So if A is equal to 200, S is equal to 500. Now, we want to know for S though, for T, it wants to know what if we, instead of charging $10 for adults, we charged $15 for the adults. So what is 5 times 500, which is our S? That would be 2,500. Now we have 15 times our A, which is 200. What's 15 times 200? Well, that would be 3,000. If you add that together, that's going to be 5,500. And if you subtract the 4,500, that's going to give us the difference of $1,000. That would make $1,000 more if they were to charge $5 more for the adults. And we know that because 5 times 200 is going to be 1,000. So instead of it being 10, we just had multiplied the 5 times 200. That would give you the 1,000. Now, 8 says, let's skip 8. Don't do 8. You don't have to worry about doing 8. Okay? Yes, so now let's do 9. Jack is 27 years old. Oh, nope, that's not what that says. It says Jack is 27 years older than Susan. In 5 years, he will be 4 times as old as she. Find the present age of Jack and Susan. Well, Jack is equal to Susan plus 27 years, right? He's 27 years older than Susan. So Jack plus Susan is equal to 4 times Susan plus, oh, that looks like a 5. Susan and 5 years. 4 times as old as she is, but it'll be 5 years from now. Okay? Find the present ages of Jack and Susan. So Jack and Susan is equal to 4 times Susan plus 5 years. Now, once again, you're going to have to solve for one of these equations here. So let's do this. Okay. This is plus 5. Sorry. That's not J and Susan. That's J plus 5. Because 5 years from now, how old will they be? Okay. We know what J is. J is S plus 27 plus 5 is equal to 4S plus 20. All right, so now all we got to do is solve. Susan plus 32 is equal to 4S plus 20. I'm going to do 2 steps in one. Okay? 2 steps in one. I'm going to subtract 20 from both sides, and I'm going to subtract S from both sides. This cancels. This cancels. That leaves 12 equals 3S. If I divide by 3, S is equal to 4. So now Jack is equal to 4 plus 27, so he is 31 years of age. And Susan is 4. Now, what calculations would you do to check to see if your answer is correct? So how could we prove that? How would we do that? All we have to do is rearrange our equation up here. We could say Jack minus 27 equals Susan. Is that correct? Well, 31 minus 27 is equal to 4. It checks out. Page 9. Number 10, double A. All right, this is where you have to be really, really meticulous, very precise, very exact. Okay, find the product. These are two trinomials multiplied together. We have to multiply each term of the first polynomial or the first factor by the second polynomial. Okay? So, be very, very careful. We ready? What is x squared times 2x squared? That is going to be 2x to the fourth. X squared times 3x plus 3x to the third. Because when you're multiplying exponents, you add them. X squared times 2 is plus 2x squared. We're done with that. Get rid of it. Okay, I'm going to go ahead and erase those. Now what's x times 2x squared? That's going to be, oh, that's a negative. All these are negatives because we're multiplying by a negative. So we're going to minus 2x cubed minus 3x squared minus 2x because this negative. So now we can get rid of that negative x. Now and so since it's 1 times all of this, all we have to do is write it down, right? It's just times 1, so let's just write that down again. Now we got to combine like terms. Here we have an x cubed, no x cubed. So 2x to the fourth. Combine these is going to leave you with plus x cubed. Now we have x squared, x squared, x squared. We've got to combine those. Well, the positives is 4x squared minus 3x squared. So that's going to give us a plus x squared. Now our x's are simply negative 2x plus 3x. So that's going to give us a plus x. And then we're left with this plus 2. There you go. It is that simple. Yes, I agree. Now, 10BB says, use the results of part A to factor 21 and 112 as a product of a 2-digit number and a 3-digit number. Okay? Use the results to factor 21 Okay, so that is actually, I think it's supposed to be 21,112 as a product. Okay, we're going to factor 21,112 as a product. Okay, now, just looking at that, we have 2, 1, 1, 1, 2. Now look, we have 2, 1, 1, 1, 2. What do we need those x's to be? If we make those x's 10, we get our answer. 10 to the fourth is 10,000. Well, 10,000 times 2 is 20,000. And then 10 cubed is 1,000. So we would have 21,000. Okay? So if we use that idea, let's go back up here to our original problem. And if we plugged in a 10 for x, we would have 10 squared minus 10 plus 1. times 2 times 10 squared plus 3 times 10 plus 2. Ooh, good. Now, this is 100 minus 10 plus 1. What is that? 91? So this is going to be 200 plus 30 plus 2, 232. There's our binomial times a trinomial. Or, I'm sorry, not a binomial. 2-digit times a 3-digit. Is 91 times 232 21,100? Yeah, 112? Sure, it is. All right, page 10. Number 11. The local theater in Jamie's hometown has a maximum capacity of 160 people. Jamie shared with Venus the following graph that said that the shaded region represents all the people combinations of adults and children or child tickets that could be sold for one show. Notice that C would give you the values of the children tickets. A gives you the values of the adult ticket. So, CC says Venus objected and said that there was more than one reason that Jamie's thinking was flawed. What reasons could Venus be thinking of? Why could she be flawed in the thinkings here? All right. All right. We cannot have one reason would be we can't have a negative number of sold tickets. Tickets. Which would be everything over here, right? This would be a negative, this would be negative, these would be negatives. Well, we can't have that. Okay? So, another reason would be what? Everything in here is whole numbers and fractions, right? Can you sell a fraction of a ticket? No. So the second reason would be you can buy a fraction of a ticket. So, although it looks right, technically, if we got real technical with it, she would be incorrect. So DD says, use equations, inequalities, graphs, and or words to describe for Jamie the set of all possible combinations of adults and child tickets that could be sold for one show. All right, so let's think about this. We would say for C plus A, what would they have to equal? They would have to be less than or equal to 160, right? The maximum capacity is 160. Could they sell less than 160? Sure. You don't always sell out a theater. And what would A have to be? A would be greater than or equal to 0. C would be greater than or equal to 0. Could you sell 160 adult tickets? Sure. How many children's tickets would be available then? 0. Could you sell 160 children's tickets and 0 adult tickets? Theoretically, yes, but we ain't going to put 160 kids in a theater with no adults. All right, so no, we wouldn't do that. But yes, theoretically, according to this problem, we could do that. Okay? That would work. Now, let's see if I put another one on there. EE says the theater charges $9 for each adult ticket and $6 for a child ticket. The theater sold 144 tickets for their first showing of the new release. The total money collected for ticket sales for that show was $1,164. Write a system of equations. Find the number of child tickets and the number of adult tickets sold and solve the system algebraically. Summarize it. Okay, so here we go. We've already done the hard part. What is $9 for the A plus $6 for the C? And that's going to equal, since we're talking about dollar amounts, that's going to equal 1,164. And we know that A plus C is equal to 144, right? They sold 144 tickets. Now, all we have to do is solve this algebraically. Simple, right? All we have to do is okay. I'm going to do this one a little bit different. If y'all are okay with that. We've already done one where we substituted. We found out A or we found out C and we substituted that into the equation. We did that, right? Let's do elimination now. To do elimination, we're going to try and get rid of either A or C. How can we do that? Well, if I multiply this by a -6 and multiply this by a -6, I'm going to get rid, if I combine the two equations, I'm going to get rid of C. Okay? So this would be 9A plus 6C is equal to 1,164. What's a -6 times A? What's a -6A? What's a -6 times C? What's a -6C? What's a -6 times 144? -864. Now we're going to combine these equations, which means draw a line under it, combine going vertically, because that's your common terms. You can combine the A's, you can combine the C's, and you can combine the total dollar amounts. If we do that, C's gone. Done away with. 0C, we don't care about it. We are left with 3A is equal to, what's that? 0, 0, 300. Divide by 3, divide by 3. A is equal to 100. Well, if A is equal to 100, C has to be 44 because we have a total of 144 tickets sold. There you go. Page 12. Excuse me. This is a recent, let's go ahead and stop